Hi fellow enthusiasts, welcome to my channel. Let's go into today's video and we're gonna come back at the end to wrap it up. So in today's episode, I want to show you this Crystal FM transmitter. We've built this before, so it's not really new to us. We've built it before and you can see it working on the screen. Hello. So I'm testing it right there. You can hear me through that. I'm gonna mute myself from the computer so you can hear me only through the radio. Alright, so can you hear me through the radio? Alright, so I'm just speaking through the radio. You can see on my laptop, that's the microphone right there. So let's light up this place a little bit. And yeah, so that's the microphone. And then there's a crystal, a capacitor used to connect from the microphone to the rest of the circuit, and then this biasing resistor, 3K3. I'm going to show you the circuit diagram later. Then you have the preamplifier here. So we just added this crystal to the preamplifier, and that's how we got it to be a transmitter. Previously we said you needed this capacitor, but in this episode you don't really need it, even though we still used it. What is new here is this inductor and capacitor here. So we're going to talk about it. Remember, in this series we're talking about how to make inductors. So we're going to talk about that inductor briefly. And but before we talk about it, let's demo some things and then we'll come back. So I'm going to unmute myself from the computer so you can get my voice clearly. Alright, so I think you can hear me through both the computer and the radio. And what I want to show you on the radio, I'm getting some acoustics, so let's see if we can fix that. Maybe we should turn off the radio first. Let's reduce the volume from the radio. Alright, so what you have on the screen there is the, let's remove the insert because the insert is really blocking your view. So let's remove that. Yeah, so what you see on your screen now is the software defined radio. We're using this to pick up the signal from our transmitter that we just built, right? The crystal transmitter. And right there where you see my cursor, or where you see the red line, is where the signal is, right? So when I turn off the radio, I'm just going to pick it up and remove the power. You can see the signal just gradually vanishes away from this spot. I'm going to plug the power back, and you notice what happens there. So let's go power in. You can see the signal that just comes up as soon as I plugged it in. And when I'm talking, the signal is fluctuating, showing you that there's strong signal coming in that area, right? So you can see there's very strong signal in that area. Now I'm going to remove the power one more time, and it goes away. Right, there's other spurious signals around it, but not the one on this red line. So I'm going to put the power back one more time just to demo this. All right, now as soon as I put the power, you can notice that huge spike in signal. Now we're using a 27 megahertz crystal, which means that we should receive the signal also at 54. So let's go 53 now. 53. I'm saying 53 because of these points here. So the signal should also be here. How do we? There are other stations around here, so making it difficult for us to really see our own signal. So I'm gonna remove this headphone. I don't know if it's okay. Maybe I should just leave it in. Anyways, so we have to check the gain. Let's reduce the gain because I think there's a very strong signal nearby. Alright, so reduce the gain. Now, so let's see if we can notice when we plug in our power supply. Positive. Alright, did you notice anything? Let's see. Yeah, I think I could notice something right around here. So we're going to fine tune to be on that spot. So let's go and see if we can hit that spot. Right about there. Right, so when I remove the power, it goes down. But you can see the signal is really weak from our transmitter. On 54, signal is weak. Now let's go on 27. 27. That will be 26 because of the decimal. So 26. So around here you can see, yeah. So when I plug it in, you can see the signal is around here. So let's just fine tune. Sorry, we should be going up a little bit. Right about there. So let's check the volume. Let's see. Hello, hello. Yeah. Bandpass filter. Yeah, really, the bandpass filter is doing over job. Let's. Yeah, let's try to go on 54. To get anything from here, so let's try. You can still hear it, but really dim. The sound is really dim. So let's try 108. Than 54 and 27. Most is working better than 54 and 27. So why is that? Yeah, the wires are really yeah, you can hear some of this. So the wire is shaky. I don't know why that is. But I just want to show you something here. At 108 or 107.958, the transmitter works much better than 54 and 27. So I'm going to leave the settings the same, and I'm just going to move back to 27, 54, and back to 108. So let's try that. C letter band 27, alright. You can fine tune it a little bit if you want, but let's go to 54. 4. You can see, even looking at the signal, the strength here, the sound is really the signal is weaker for. Let's give it 108, the signal is much bigger. Right. Much bigger, much clearer. And that is the reason I'm making this video, to show you these differences. So let's go to 135. So that's 27, adding 27 here, then 134. So let's do Our best signal comes the
The
best
best
signal
signal
quality
quality
comes
comes
at
at
108.
108.
Now,
Now,
why
why
is
is
that?
that?
That's the
That's the
whole
whole
reason
reason
for
for
this
this
video.
video.
Remember,
Remember,
when
when
I
I
do
do
my
my
videos,
videos,
I'm
I'm
gonna
gonna
turn
turn
this
this
off
off
because
because
the
the
wires
wires
are
are
still.
still.
I
I
held
held
it
it
in
in
my
my
hand,
hand,
so
so
let
I'm
me
gonna
show
show
you.
you.
All right. So the wires are really shaky. I'm gonna show you how the wires are connected. When you do yours, please make sure you solder them, or you use a more stable connection. So let me just turn on the camera so I can show you what I mean by that. So you can see the wires and the antennas, they're just hanging. They're not soldered. So make sure you solder your wires and don't have your batteries hanging this way. And so you can see some wires really hard to see because I'm using this very tiny camera today. So you can see all the wires hanging around. So don't do it this way. Let me just unplug it and show you. The whole reason for this video today is to show you the purpose of this inductor and capacitor. That's the whole purpose of this video, the inductor and the capacitor. All right, so let's just go and do a circuit diagram and then we'll come back. All right. All right, do this video and make sure you do better than this one here. All right, so build this circuit. So what we did was we have a transistor amplifier, and we did this before, but we made a mistake in the drawing. The building was fine, but the drawing was when we connected the crystal, we made a mistake. But this is better. So you have your output here. So this is really a transistor amplifier. So here we used 5K6 and here we use 56K and here we use 2N2222. So power supply is here. You can use 3.7 volts. So that's what we did. We built this amplifier before. We've done it several times as a preamplifier. You can see it in the preamplifier for Hacker World 1 transistor FM receiver. So we built this and we just did it again on purpose, right? So let me show you why we did that. So remove this. Let's remove that output and just put a wire here. So what we did was we put a crystal here. Exactly the same thing we did last time. And when you have this crystal, just bias the microphone, the condenser microphone this way, ground. We use 3K3 here. This is also positive, so you can just tie them together. All right, and then from here, we have a capacitor to here. So if you like, you can add a volume control over here. So if you want to do that, just have a variable resistor. This one ground, this goes in this, so the capacitor will connect here to the resistor, microphone, ground. You can do it this way. So this is that 3K3, and this one goes into the amplifier. You can use 50K here if you will. Use 1/50 volts here. So if you want to add volume control to it, so this system will just go in here. All right. But that's not the reason we're doing this video. So the reason we're doing this video today, you can anyways pause it and take the circuit diagram. I'm just going to delete it now. If you want, I can draw the full circuit diagram for you. So let's just delete that. Right. So the reason we're doing this video today is we've talked to you about the what's it called, harmonics. We've talked to you about harmonics before, and harmonics is just an integer multiple of the fundamental frequency. So the crystal we use here was the 27 megahertz crystal, 27. That means at every integer multiple of that frequency, you can get the signal again. So so that means at 27, at 54, at I think it's 81, at 108, and then at just add 27 there. So that's at 135, and so on and so forth. So at all these frequencies, you receive the same signal. But this is your fundamental frequency. Then this will be just the subsequent frequencies as you go down, or the different harmonics going down. So sorry, I think this is your F1, not F0, but F1. So your fundamental of F1, some people call it F0, but 2, 3, 4, 5. I did this on purpose because your fourth harmonic is 108. Now, so why is it strongest at 108? Is it just because it's the fourth, or what? No, it is not. The reason it is strongest at 108 was because we introduced. Remember that capacitor was telling you about, an inductor, variable capacitor and inductor. What we did was we built a high pass filter. So a high pass filter has a capacitor here and then an inductor this way. If this is your in or V in, let's just call it V in. This is your V out. This is ground. What happens is that your output is maximum when this is at resonance. When your LC is at resonance, so this is your C, this is your L. When they're at resonance, the output is highest. So the impedance will match and for some reason cancel out such that your output, the amplitude will peak at resonance and drops that way. So in this place, you have to design your LC to correspond to your desired frequency band. In our own case, we wanted it to correspond to 108. So we just found the value for L and C that will give us the maximum amplitude. So if this is amplitude or voltage, and then this is just the frequency, right? So that's what we did. So how do you find the value? The value is F. You can just say FC, your cutoff frequency, is equal to 1 over 2 pi square root of LC. That's what we did. And we picked a value. We picked one value. We picked a capacitor and we built an inductor. We know our FC. The target FC for us is 108, and 2 is a constant. 2 and pi are constants, so 1 over. Then square root of L we are going to calculate. We put asterisks on it. But C we know. We put 5 picofarads here. And then we rearranged the formula and found the value for L. And that's all we did. But then remember the calculator we've been showing in this series. So we use that calculator to find this value. And then we'll just go backwards and and find the number of turns, the length, and the rest of them for us to make that inductor ourselves. So we made 12 turns inductor. With the number of turns T is 12, and then we say that our D, we found our D to be 0.249, and then the L, which is the length of magnetic circuit, we found it from experiment, I think around 0.434, something like that. When you plug all this into the calculator, it gives you the inductance that you need to satisfy this circuit. And that's all we did, right? We did that and we found a value that works for this circuit. So let's show you that calculator one more time. Okay, let's go there. All right, so we're gonna go to the calculator. Let's just um, I'm gonna try to show the screen now. All right, the screen is frozen here. So what's going on? let's go back here. um yeah, the screen is frozen for some reason. This is weird. So I guess we're gonna disconnect all this. All right, so let's see if it works now. Right, so here is the calculator. Hopefully everything is still showing on the screen, but here's the calculator. And then in the calculator, we're calculating for F. We're calculating for inductance, sorry. So we give our frequency, which is 108, and then the capacitance we have already is 5, and then we found out that we need 0.434 uh 0.434 for our inductance. So this is P in picofarad. Sorry, this is we need 1, 2, 1, 2, 3. Yeah. So we need 4.4. This is picofarads. One more zero. Yeah. 3 and 3. Yeah. One more zero. Yeah. So we needed 5. So we have no, we have 5 picofarads. 5 picofarads. 5 picofarads. That's just 5 picofarads. And we needed 0.1 microhenry. 0.1, 0.4. And then so no, this is actually 0.4 Henry. 0.4 Henry. So you have to make an inductor this value, because this value is in Henry. So this, you have to make an inductor this value with this capacitor to give you this frequency. So you just make the coil. So inductor value here, diameter, you measure the coil, and then the length of magnetic circuit, you have to measure that. I think we got about 0.4 or thereabouts. And then the number of turns, we got around 12. So the value you're looking for is 0.435 microhenry. So this is the value you got, 0.435 microhenry. So if I have this, let's go here and check 0.435 microhenry. Let's just do that. So I'm going to copy that value, and I'm going to calculate frequency. My frequency again is 108. Frequency is in this place, so I can't change that. All right, so I can change this, my inductance in picohenry. So let's just put the value here. But again, now I have to multiply this by, because I got it in microhenry, I have to multiply it by 1 million. So that's gonna be plus 5, and then the inductance is 5. So if I have an inductance of 0.5 microhenry, or 500,000 picohenry, and then I have a capacitance of 5 picofarads, then my frequency will be around 107 dot some values. So if you move this 1, 2, it's going to be 107, 107.81 something. This will be your cutoff frequency. The best frequency for this transmitter to work will be around here. So you can understand why we are working, why we're operating best at 107.97 something or 87 something. So this is how you do it. So you build a capacity an LC circuit. I still hope that this is streaming. If you can still see my screen, hopefully. It doesn't seem to. I don't see the golden sign around my screen, so I think I'm just talking in vain. I'm gonna check, but in the meantime, so that's what you do. So build your oscillator, build your transmitter. Let's just show the same circuit. What is it? Yeah. And then at the output, just put your capacitor and then put your inductor and then connect your antenna here. So for our antenna, we have another capacitor here that goes to our antenna. This capacitor wanted to have the impedance XC to be approximately 50 ohms. So you just find a value for here. So XC is equal to 1 over 2 pi FC. We know our F, which is 108. So calculate a value that will give you XC to be approximately 50 ohms. When you do that, you're gonna get C to be approximately 29 picofarads. All right. Thanks for sticking around to the end. That'll be it from us today. Please, if you have not subscribed, do so right now. And don't forget to like and share this video. Until we come your way again with more contents, stay enthused.